first test on geomorphology, climatology and oceanography is completely catering to the needs and requirements of the students for physical geography. Now when we go on to say physical geography and this segment of physical geography, then this segment of physical geography happens to be very logical, it's very empirical and very diagrammatic and illustrative as well. The one thing that the students have to keep in mind while answering questions in this section is that they have to be very compact in writing answers with a use of lot of terminologies in this case. Because the terminologies help any candidate to condense his answer, to compact his answer. It's the compactness in this case that will go on to help the candidates to put a good amount of facts and also go on to express themselves in a somewhat different manner and also in a much more positive manner with a variety and also the amount of content being very large. Of course, the questions of geomorphology, climatology and oceanography will be different, and some of these topics may go on to be carrying a degree of analytical tinge as well. By and large, most of these questions go on to be conceptual in nature with some degree of explanation. The first question, that is 1A, that is about discuss the origin, exploration, extraction and processing of mineral resources. Now this is a question that goes on to be comprising of 4 sections and generally it will be expected that this is going to write 50 words on each of these sections. These sections go on to include formation, that's one. Second is exploration, extraction and then processing of mineral resources. The candidates have to begin by answering how is it that the mineral resources go on to form. That's the first bit. There are minerals that go on to form in a variety of ways, and once they go on to form, then they have to be explored. That means it's about reconnaissance and it's about exploration, it's about surveying of the surface, and then extraction, that is mining technique. And once they have been mined, how is it that the minerals are going to be processed in the form that how is it that they are going to be, the gangue is going to be separated from the ore. The formation of the mineral resources is going to take place in different manners. One of them is magmatic process of formation. Second is sedimentary, where sedimentary rocks are going to be formed. The third is going to be hydrothermal. Hydrothermal is different from magmatic in the sense that is in hydrothermal, it's the fluid that goes on to emanate out of a magma or a magmatic activity carrying a good amount of minerals that goes on to get deposited in some place. Sedimentary will go on to include certain things like formation of some type of banded iron ore deposits like what goes into in Dharwad, and then the placer and detrital minerals which are going to be deposited like the one that goes into in Orinoco River Basin in Venezuela, in Colombia and Venezuela. That's one. Or it can go on to be the placer deposits that goes on to be in Bikaner in India. That is the origin of mineral resources. So 4 forms of origin: magmatic, hydrothermal, sedimentary and residual. Of course, residual will also go on to include supergene sulfide enrichment. The second is exploration. Exploration is going to be done in field and it goes on to begin essentially with an aerial survey. It may go on to begin with remote sensing satellite as well, and then on the ground level it is going to be done with the help of a geologist who will go on to move with his bag and package to a variety of regions, keep on picking up some amount of samples, and once they have picked up these samples, then they will go on to go send it for the purpose of testing. So in this manner people will come to know how is it and where exactly the mineral resources are in what amount. After having done that, they will go on to follow a variety of methods to calculate the reserves. So they will go on to insert one copper rod in one place, another copper rod in another place, and then going to pass electricity through that. If the conductivity of the electricity is going to be high, then it goes on to mean that there is a good amount of copper deposit in that place. It may be indicative even of silver and gold as well, but then that is going to be one of these methods. So this is going to be assessed with the exploration method. The third is assessed with extraction, and extraction can go on to be in the form of open cast mining, open pit mining. It can be in the form of quarrying. It can go on to be in the form of Shaft mining. Shaft mining will going to comprise of a lot of underground mining techniques, like one of them can be pillar and board mining method, the longwall mining method technologies, the advancing longwall, the retreating longwall, and some of the methods that we have practiced which have not been very, very fruitful. That's called as the Chowkidar method or board and pillar, the variant of board and pillar method. That's the third segment. The fourth segment that the candidates are going to be writing about is once extracted the mineral resources required to be processed. Now processing will go on to include how is it that the gangue is going to be separated from the ore. The separation of ore from the gangue goes on to be with the help of a radioactive method. It can be the help of a magnetic method. It can be in the form of a Humphreys spiral. It can go on to be in the form of washing of these ore deposits with some type of chemicals also. All in all, it is about the enrichment of the ore that we have obtained. Now, having written that, the candidates do not require to conclude in these, because the question required to answer 4 different segments, and then the expectation was that they can go to write 2 different paragraphs on that. Not exactly that the candidate have to say, thus we see that there have been 4 methods and there are 4 segments of it. That's not required. And in any case, most of these questions go on to be of 100, 150 marks and so on. So that's what we'll go on to take care of. Second of this question is what are U-shaped valleys and its associated forms? It's 1B. U-shaped valley is a glacial erosional valley. It's a glacial erosional feature. So it is a glacial erosional feature. This glacial erosional feature is formed because of quarrying, because of scatteration, because of plucking, and because of abrasion. Once the candidate goes on to explain what are glacial erosional features, then he will go and say the most prominent of these glacial erosional features are going to be U-shaped valleys. Then thereafter they will go to come to this segment, how is it that they are going to be formed. The basic method of their formation is that a glacier, main glacier with a high amount of a load of the glacier is able to excavate its valley much more deeper, and these were some of the valleys that were water occupied and they were riverine occupied, and once the glacial ices went on to dawn, then the same rivers have been transformed into glaciers. So it leads to formation of not a V-shaped valley, rather a U-shaped valley. This U-shaped valley will going to have many associated features. One of them is going to be truncated disperse. Second is going to be hanging valley, because truncated disperse and hanging valley, both of them going to be side by side. The U-shaped valley is and on the base of the U-shaped valley there will be a lot of lakes. These lakes will be linear lakes, there will be finger lakes, there will be certain type of lakes that will be extending for a good amount of a linear distance as well. And then some of the features like rush and mutanies, that is in general language that we're going to be calling it a sheep back, a feature, crag and tail. The whole of this U-shaped valley goes on to descend down the valley in the form of a glacial stairway, and it goes on to be having lot of rock barriers as well, called as Rizal, Regal and Trade. It's some empirical part, and that will go on to require a good number of diagrams, at least some 7 or 8 diagrams. Candidates, once they have talked about these diagrams, talked about these features, and then they have gone to draw their diagrams, then if the answer goes on to be comprising of 10 marks, they won't go on to get less than 8 marks in this topic at all. That's the second question. The third question is going to be about what are beaches, and discuss different types of beaches in this formation. The answer structure will be what are beaches. Beaches are essentially depositional features. The candidates don't have to make any blunder of sorts that they have to write that it's an erosional feature. It's a depositional feature, and these beaches go on to be of a variety of type based on a shape, materials, the color of the sand and its location. On the basis of shape, the beaches can go to be linear, they can be cusp shaped as well. Linear beaches like that of Marina Beach in Chennai, that has been a wave cut platform, wave deposited platform rather. Cusp shaped beaches go on to be the excavation of the materials which go on to be showing some amount of a differential erosion of the hard and the soft rocks. That's one. Second is on the basis of the type of materials that go on to form beaches. Beaches can be shingle, which are made of rough stones which are going to be made of large stones. And these shingle beaches, which are sometimes also called as storm beaches, are formed by gravels, and they are going to be formed by large materials. Coral beaches are the one that go on to be formed because of the coral deposits. Pink beaches, of course, go on to be formed also because of the same region, and they are made of limestone. Mostly, sandy beaches are the one that go to be made of sand. So one of them is going to be made of gravel, another goes to be made of sand, another going to be made of limestone deposits. That is on the basis of the material formed there. The third is on the basis of the color of the sand. So if there has been a granitic erosion of the surface, it will go on to lead to formation of a golden beach. It will go on to lead to a white beach as well. But had there been some basaltic rocks, and the basaltic rocks have got themselves degraded, that will go on to lead to formation of a black beach. The type of beaches that one goes on to find in Azores, in Madeira, in Galapagos, even in India, it goes on to be some places like that of Kovalam as well. So black beaches in Anjana is going to be a part of it. So black beaches can be on the basis of color. On the basis of the location, the beaches can go on to be bay head beaches. That means beaches that are going to be located on the bay, on the head of a bay. Now most of these beaches go on to form because of differential erosion and because of the excavation of the intervening areas between the cove and the headland. Lagoonal beaches are the ones that go on to be on the head of a lagoon. So some of these type of beaches can be in some places like that of Baleshwar. It can go on to be in Orissa. It can go on to be in South India as well. In some places which go on to be at the head of a lagoon. So once a lagoon goes on to form, and then there is going to be a beach that is going to be on the head of the lagoon. Such type of beaches are very good to bathe on. The question required only this much amount of information. Again, in this case, no conclusion of sorts was required. The fourth question is going to be on Rossby waves. Discuss the origin and movement of Rossby waves. The fourth question is going to be on the origin and movement of the Rossby waves. So what the candidates have to do here is that the first is they have to explain what are Rossby waves. It's only after that they have to talk about how is it that these Rossby waves going to originate, and then thereafter they're going to talk about how is it that they're going to move as well. Rossby waves have to be explained in the form of a jet stream. Essentially, Rossby waves are jet streams which go on to move in the upper atmosphere in a spiraling manner or in a serpentine manner in the upper atmosphere. So they are extension of jet streams, and they are jet streams itself. They go on to blow from west to east. The best way in this case is that the candidates can go on to enumerate the characteristics of the Rossby waves. The first characteristic will then go on to be that is Rossby waves go on to blow in the upper atmosphere. The second is that they're very long waves. The third is that they're going to be having a wave crest. The fourth is that they're going to move very fast. The fifth is that they go on to move in a spiraling manner. The sixth is that they are associated with the transfer of energy from equator to the poles. The seventh is that the Rossby waves go on to determine a lot of weather conditions, etc. Having explained that, that will be the second component is going to be associated with the formation related to jet stream. Now, jet streams form because of three reasons. First is as the thermals go on to move from equator to the poles. Then these thermals, as they go on to descend from 18 kilometers of troposphere at the equator to 8 kilometers at the poles, then there is wind speed increases. The second reason for a wind speed increase is going to be because they're going to move from, these thermals going to move from high pressure to low pressure. The third reason is as these winds go on to descend from high pressure to low pressure and go on to move from equator to the poles, then under such a condition, in such a region, the Earth's radius, because it is decreasing, it allows conservation of angular momentum. And considering that mvr is equal to constant, the radius goes on to decrease, the velocity must go on to increase, and because of increase in velocity, the winds go on to pick up speed. The fourth is that as the winds go on to pick up speed, at the same time they go on to get deflected towards the right hand side because of the Coriolis force. Meaning that is all these high velocity winds that have now evolved, they will start moving from west to east. These high velocity winds moving from west to east, sometimes they go on to encounter the obstructions in the form of Andes Mountains, Rockies Mountains. Now, as these high velocity winds go on to move and they're going to encounter obstruction, then these are winds that are going to be moving in the form of a vortex. They're not moving in the form of a straight line, they're moving in the form of a vortex. And once this vortex starts moving, then in the process of formation of this vortex, they move towards, they climb. As they're going to climb, then they're going to move towards the northern hemisphere in order to conserve angular momentum. And once they're going to be on the top of the mountain, they're going to move towards the northern hemisphere, towards the polar regions to conserve angular momentum. And once they're going to move down, they're going to move towards the equator again in order to conserve angular momentum. Now, in order to conserve angular momentum, when the winds go on to cross any such type of a barrier, they're going to move towards the poles and then towards the equator, and then that goes on to set the entire of the jet stream in such type of a oscillatory motion, in such type of a spiraling motion. Such type of a spiraling motion that the jet streams go on to experience is what we're going to be calling it by the name of Rossby waves. It is these Rossby waves that have been found to be generated in the upper atmosphere, and then they're going to move from west to east. As they're going to move from west to east, they are associated with the generation of a lot of weather phenomena on the earth, and they are also associated with high pressure and low pressure conditions that are going to evolve on the earth. That is question number 4, 1D. That goes on to bring us on to question number 2, that is 2A. This is the question is, analyze the possible impact of sea level changes on coastal economy. Now, this is a question that goes on to be comprising of some section of maybe geomorphology or oceanography and some section of economic geography. Questions in this question is going to be of an interdisciplinary nature. Now, in order to explain this question, the first thing that the candidate has to explain is what exactly is coastal economy, because coastal economy is the one that is going to be asked, and that has been asked here. The components of coastal economy will go on to become, one of them is agriculture, second is industry, third is transportation, and the fourth is tourism. Now, what the candidate has to do is that they have to analyze the impact of the sea level change, that is whether the rise in the sea level or a fall in the sea level is going to be impacting agriculture, industry, transportation, or tourism. Take the case of one of them. So that is going to be impact of rise. So what exactly will be the impact of rise on agriculture, industry, transport, and tourism? And what will be the impact of fall on agriculture, industry, transport, and tourism? The impact of rise on agriculture can go on to be salinization, eating away of good farmland, that is happening in Bangladesh. The third is inundation and also intrusion of the seawater that is associated with all of its demerits. With respect to industry, the rise in the sea level can go on to mean it goes on to eat away the industrial areas, and it can go on to increase the overall cost of infrastructure, because some people who have established their farms or factories in that region, they may be required to protect their region by building of an embankment of sorts, that marine embankment, coastal embankment, that will go on to lead to an additional cost incur. Transportation can be, that means if a railway line happens to be passing through this region, then that will go on to create a problem, that is abrasion of the rail line. That can be one of these factors. And the second of this factor can go on to be in the form of if the waves go on to be strong, sometimes off and on, then the trucks will go on to get themselves inundated. It does happen in one or two places in the world, but then generally it is not going to be a common phenomena. That is going to be on transportation. Tourism is going to be the third one, that is the impact of sea level change on tourism can be fatal, in the sense that is most of the tourists can go on to be a bit skeptical of the fact that the sea level is rising and that the beach area will go on to get itself constricted, it will go on to get itself subsided, and the entire of this region will go on to get very, very narrowed down. While the impact of rise in the sea level is easily discernible, easily explainable, the fall in the sea level will not going to have too much amount of impact on agriculture, industry, transportation, tourism. But then On agriculture, the impact of fall will not be so much as it can go on to be in certain things like that of tourism, because a fall in the sea level in a coastal area will go on to imply that the beach area goes on to become extensive, and that may go on to become better from the perspective of tourism. But then it is not going to be for all of them. Now this answer can go on to require some degree of a conclusion, in the sense that is, the conclusion can go on to be that impact of sea level definitely goes on to improve, or that goes on to destroy the coastal economy. That's 2A. 2B is going to be all about river ecosystem, that is a riverine ecosystem. The significance of riverine ecosystem is going to be that it's an aquatic ecosystem, and the basic significance from the perspective of ecosystem is that a good number of fishes which go on to migrate from the coastal areas to the sea for the purpose of giving birth to their young ones, for breeding. Tidal boats going to be helping in that. Second is the entire of the region that is going to be the estuarine region, that goes on to be one of those regions that is explaining the mixing of the seawater with the fresh water. The mixing of seawater along with the fresh water is significant because such a mixing goes on to lead to formation of brackish water, and which goes on to be a completely distinctive ecosystem. If such a mixing doesn't go on to take place, then the whole of this region will go on to become completely freshwater ecosystem. The third is that such type of tidal boards go on to also aid the evolution of the mangroves in this region, because the mangroves go on to be essentially brackish water ecosystem. These were the three more important significant aspects associated with riverine ecosystem. Third question on C is application of climatology to transportation. Now this question doesn't going to be comprising anything like discuss, elaborate, elucidate, because in 200 words that may have gone on to become a bit difficult to explain. While explaining the factors that are going to be affecting transportation, the first thing that the candidate has to do is that they have to explain the components of transportation. So it will going to be rail, road, marine transportation and air transportation. That means what is going to be the effect on the rail, on the road, on the marine transportation system, as well as on air transportation system. And that is with which components that the effect is going to be. So one of these components in this case can go on to be something like temperature. What is the impact of temperature on rail, road, marine and air? What is the impact of winds on rail, road, marine and air? What is going to be the impact of rains on rail, road, marine area, and so on? And they have to give an example of each one of them. The role of temperature on a rail transportation is that it can sometimes go on to associated with the twisting of the rails. On the road, it can go on to lead to the formation of mirage, and sometimes associated with the melting of the asphalt tracks. On marine, temperature hasn't got too much amount to inflect, or on air as well, it doesn't go to have an impact as much as it can go to have here. Winds can go to have an impact on no rail and road transportation, but it can go to have on the marine transportation. The basic impact of wind is that the waves are going to become very, very rough. In marine transportation, that means open seas, and that goes on to become make navigation very difficult. On air transportation, winds go on to play a major havoc, and it can go on to aid the air transportation as well. For example, how it goes on to aid air transportation is that most of the pilots going to leave themselves in the jet stream, and once they have left the plane, they are very comfortable with the fact that they are drifting away with the jet stream. So that way it goes on to aid the air transportation. It goes on to harm air transportation if the plane is moving against the jet stream, or it is going to be moving across the jet stream. That's one. Second is air can go on, winds can go to affect the aeroplane in other way as well. That means when the aeroplane is going to land, and if there is development of a crosswind, a very strong crosswind, that may go on to allow the planes to skid off the runways, and they may have to again retake off in this case. So that is one aspect that a climatologist must go on to know. Rains can go on to have an impact on the rail and road to a minimum extent. Maybe in the sense that is the byproduct of rains that can go to be floods. So floods will go to affect road and rail transportation. Marine transportation doesn't going to be having too much amount of impact unless it goes to get mixed with a high velocity winds. Air transportation can going to be significant because it goes on to affect the landing and the takeoff of the aircraft. That is where it goes on to having a major impact on air transportation. Fog goes on to be having a major impact on all of them. It can go on to be on the rail transportation, road transportation, marine transportation as well as air transportation. That is the most devastating impact that can go on to be with anything is going to be rail, road, marine or air, all of them. That is a fog. For example, a fog will go on to allow trains to miss an accident. Of course, road accidents do going to be taking place. If some of you recall that it was fog or may have been, may not be, we are not sure of it, no one for that matter is sure. That is, it was again a very dense fog condition that may have led to the sinking of Titanic, and of course air travel, it can go on to be fatal sometimes. Of course, a good amount of aeroplanes are now fitted with instruments which can go to allow them to land even in dense foggy conditions as well, and some of these pilots are going to be having this type of a skill as well to land the aeroplane in such type of a condition. So fog can go to be having a major impact on that. Some of these factors like cyclones can go to have a major impact on all of them. Tropical cyclones, particularly on rail, road, marine or air transportation. That means when there is a tropical cyclone, then rest assured there is no form of transportation will be functioning in that place at all. That is question number 3rd of C. That goes on to bring us on to the question number 2nd D, that is causes of geomagnetism and impact of polar reversal. What the candidate have to do here is that they have to explain geomagnetism. Now, geomagnetism is explained in the fact that the earth goes on to behave like that of a bar magnet. Of course, there is no such thing as a bar magnet in the earth, but then it goes on to behave like that. Earth goes on to be having a magnetic field that will go on to be having its north as well as its south, both of them. So meaning is that the earth goes on to behave like that of a bar magnet. That's one. That's the meaning of it. Second is the origin of the Earth's magnetic field. The Earth's magnetic field goes on to originate because of the peculiar structure of the Earth and some amount of movement that takes place inside the Earth. For example, the inner core is solid. The outer core is liquid. The liquid outer core is made of nickel and iron. The liquid outer core has a very high temperature, about 4000 degrees centigrade. Liquid outer core is always going to be moving, it is always going to be mobile, and it goes on to lead to the evolution of a good amount of convection currents in the outer core. Such type of convection currents that go on to originate in the outer core can go on to have a direction that is going to be anti-clockwise or clockwise. Now these are magnetically charged and high temperature particles. They are very high temperature particles, and when they go on to take a clockwise or an anti-clockwise direction, then following Fleming's right hand rule, it will go on to lead to the evolution of a magnetic field that is perpendicular to it. So Earth's magnetic field evolves because of some amount of a movement taking place north or taking place clockwise or anti-clockwise in the outer core, which is essentially made of nickel and iron. If the outer core materials are moving in a clockwise manner or anti-clockwise manner, then there will be a north and south pole. The north pole will go on to become south and the south pole will go on to become north when the condition of the movement in the outer core goes on to get itself completely reversed. For example, if the movement is taking place, let's say that is in a clockwise manner, maybe that then the pole is going to be north-south. When the movement goes on to become anti-clockwise, maybe that the poles will go on to become south and north. So magnetic fields go on to emerge in this manner, and then these magnetic fields go on to show a good amount of a tendency to reverse as well. The reversal of these magnetic fields is essentially responsible for a lot of things happening on the earth. This type of a magnetic reversal is called as polarity reversal, and such type of polar reversal has many impacts on the Earth and associated aspects of Earth. One of these impacts on Earth is the reversal of the magnetic field will go on to cause the magnetosphere to become very, very weak, or maybe becoming absent as well. Now, magnetosphere is responsible for the entrapment of the shortest wavelength of radiation. That is, it goes on to entrap. It goes on to be associated with the entrapment and conversion of the alpha, beta, gamma rays into many forms. Because magnetosphere goes on to with auroral display as well, and the entrapment of it, entrapment of the very short wavelength radiation coming from the sun. The absence of magnetosphere will going to imply that the sun's rays start bombarding on the surface and they start striking the surface without any protective cover, and that will go on to lead to extinction of life. So this is how exactly good amount of faunal extinction, floral extinctions have taken place in the past because of the reversal of the Earth's magnetic field. In fact, the dinosaurs may have died partly also. One of these reasons ascribed to the extinction of the dinosaurs have been polarity reversal. That has been one. That's one impact. The second impact in this case goes on to be in the form of the magnetic field of the Earth goes on to determine how is it that the birds and the migratory birds will go on to take a direction to migrate. When the poles are going to be changing, then the path of the migratory birds will going to change. They will going to become haywire because the software of theirs will not be in a position to match itself with whatever changes taking place. So they don't know where to go, where not to go. Maybe that in place of going to Siberia, they're going to land themselves up in Rajasthan desert and they'll go to die because they're going to be using the magnetic field of the Earth for a navigation tool. The third impact of the reversal of the magnetic field can go on to be on the human beings. There is a good amount of magnetite in the brain of the human beings, and because of a change in the magnetic field, then the thinking of the people, the way the people can go on to think and behave, that can go on to bring about a major change. And how is it that it can go on to bring about a major change is that, as it happens in Norway, that is during the polar winters, people start emulating a bird, they start behaving like a child. And come summer, they're going to be normal. That means they start emulating like a child, they start behaving like a child, they start moving inside the bed like a child, they start mimicking a butterfly or a bird also like a child. And this is all associated with some type of a change taking place in the magnetite of the brains. Of course, the correlationship is not completely established, but then because it happens, and because it happens in such a manner, it is a testimony to the fact that what can happen if a magnetic field of the Earth goes on to change. That was question number 2D. Coming to question number 3, this is what are the changes associated with the approaching waves towards the shore? That means, how is it that the waves are generated? Having generated the waves, how is it that the waves going to move? And as the waves go on to move, what are the changes that go on to keep on taking place? Now, waves are, a candidate has to begin by first explaining that the waves are some type of propagation of energy in the water, and it is different from that of currents and tides. Currents refer to the actual physical movement of water, while tide is the periodic rising and lowering of the water, while waves are a propagation of energy in the water. Once having explained that, they will go into that the waves are going to be generated. How is it that the waves can be generated? Waves are generated in a variety of ways. Waves can be generated because of seismicity. Waves can be generated because of winds. Waves can be generated because of some degree of a landslide taking place in the water as well. Now we assume and we go on the basic premise that is most of these waves are going to be generated by winds, and that is going to be in the sea. So they are going to be called by the name of wind generated waves. The wind generated waves that are going to be generated, they are in the sea. The place where the waves are generated is called as sea. In most of these places where the waves are going to be generated, that is going to be called by the name of capillary waves, and they are going to take place in a storm center. essentially what the winds going to do is that as the winds start blowing on the surface of the water, they're going to grip the surface. Once they're going to grip the surface, then the gripping of the surface will go on to lead to the roughening of the surface of the water. Once the surface of the water has become rougher, then a roughening of the surface of the water will go on to cause the surface of the water to develop certain type of oscillations on it. So the place where such type of things going to take place is going to be called as a storm center, and it will go on to lead to generation of one series of waves, second series of waves, the third series of waves, which are going to be called as wave trains. That means to an observer, the waves will start coming in the form of one wave, second wave, third wave, and fourth of them. So it's going to be called by the name of wave train. All of these waves that are going to be generated, they are going to be called by the name of swell. These swells will going to have a wavelength with a crest and a trough. These swells, once they have generated, they may go on to come across another swell that have been generated in another storm center or another sea. So the combination of two swells will go on to lead to the evolution of an interference pattern. This interference pattern can be of two types: destructive interference pattern and constructive interference pattern. A destructive interference pattern can go on to lead to mingling and mixing of a crest and trough of one swell with another swell. So it goes on to even out. That is destructive. Constructive can be thus, that is the crest of one swell goes on to combine with the swell of another wave, and both of them will go on to lead to formation of a super swell, and this super swell will lead to the evolution of a mega wave of sorts. Some of these waves are going to be called by the name of rogue waves, and they are very instrumental in sinking some of the ships. Some of the students who may have watched a movie called as Poseidon, Poseidon went on to sink because of this rogue wave, and rogue waves went on to generate because of the evolution of a constructive interference pattern. Once the swells start moving towards the coast, then they start getting themselves sorted out. That means as the waves start getting themselves sorted out, they actually go on to turn themselves into wave. Coming to the shore, the surface goes on to become shallow, and as the surface goes on to become shallow, the energy of the waves, in order to adjust itself with the shallowness of the water, allows the wavelength to shorten and the wave steepness to increase. The waves going to steepen, and the wavelength goes on to decrease. The decreasing of the wave and the steepening of the waves goes on to allow the waves to take a very large form. Once the waves go on to become very, very large, they go on to break. The place where the waves go on to break is going to be called by the name of breaker zone. And these breaker zones can go on to be, they can be plunging breaker, they can be interfering breaker, they can be collapsing breaker, they can be constructive breakers, and so on and so forth. The place where the waves go on to break, that is where the sea goes on to develop a white foamy form. It goes on to become completely white and completely goes on to become foamy. That is the place that we're going to be calling it by the name of surf zone. Then the waves going to move forward towards the shore. The waves that are going to move forward towards the shore, they are going to be called by the name of constructive waves. That's going to be called by the name of swash. All the waves that have moved forward, they will again going to come backward, moving at the base of the surface. As they go to come backward, that is going to be called by the name of backwash. So they are going to be swash and backwash. When the swash is more powerful, it is going to be called by the name of constructive wave. When the backwash is going to be more powerful, it is going to be called by the name of destructive wave. Now this will happen when the shore is sloping gently. It may happen that the shore is completely rocky and is completely deep at the surface. When the shore is going to be completely deep and there is no gentle sloping, there is only a rock that is going to be standing and the waves strike against the rock, then some of you may have observed it if you have gone into coastal areas, that as the waves going to strike, they are going to splash themselves 40 feet, 50 feet above the surface. Now that is the place where when the trough will go to collide, that is the sea level will be low. And when the crest goes on to collide, the sea level will be very high. So the sea level goes on to become high or low in that place, depending on whether it is undergoing a collision with a trough or a crest. This is what is called as clapeytis. Most of the waves that go on to move towards the coastal regions, they move parallel to the shore. But because they go on to get themselves dragged by the shore because of the shallowness of the coast, they go on to bend. This is called as refraction. It is because of refraction that any viewer, any observer that is on the beach goes on to see a good amount of waves coming towards his own side. And most of these waves go on to bend. If you're going to see from an aerial angle, you're going to find the waves bending. But if you are on the shore, you may not go on to possibly observe that. This is what was to be written in question number 3A. Question number 3B is going to be about a different type of erosion surfaces. Different type of erosion surfaces go on to include, first what the candidate have to do is that he have to describe it. So it's a simple question. Description means that there is a candidate have to just go on to begin by explaining what exactly is an erosion surface. And then the description of the different type of erosion surface is one of the most direct questions that the candidate can ever go on to get in civil services examination. And it's a very, very marks-fetching answer as well, because there is no complexity involved like that of coastal economy or like that of waves. The various erosion surfaces that you have to explain is peneplain is one of them. That is the last phase of the cycle of erosion. Peneplain, the last phase of the arid cycle of erosion. The second question in question number 3 is about describe and define erosion surfaces. Now this question is going to be very, very straight, very simple and very pointed as well. The candidates have to explain first what exactly is an erosion surface. That's a definition of it. Have explained erosion surface, they have to pick up different types of erosion surfaces and then they have to describe it. So different types of erosion surfaces going to include peneplain is one of them. That is what Davis talked about, that is the end of the cycle of erosion. Peneplain, that is the end of the cycle of arid erosion. Primarum, that is one of the surface that was talked about by Penck. And then endrum, that was another of this, that is the end of the cycle for Penck. H-planes are going to be tropical erosion surface, and other than H-planes, you're going to have panplains, Gipple-Fleur, stockwork, Schittler-Fleur, strat, and bomb. All of these required to be described. For example, H-planes are tropical erosion surfaces. Panplains are going to be significant erosion surface. Strat and bombs go on to develop somewhere in those places which have undergone some amount of glacial erosion. Bomb and ditch combination is something that is going to be found on the coastal regions as well. So this question was very, very empirical, very straightforward as well in this case. That's question number 3B. Come to question number 3C. This is about what is the significance of UCL and UVL and how is it that they define urban climate. Understand? What is the significance of urban canopy layer and urban boundary layer and how is it that they define urban climate? The first thing that the candidate goes on to do is that they define urban climate. So urban climate is going to be very, very different form of a climate than the type of a climate that we have generally known. That's one component here. So urban climate is going to be niche climate. It's a distinctive climate. It's one part of a tertiary circulation, and the urban climate basically goes on to get best developed in the form of urban boundary layer. That is where there is a dome-shaped formation of it. Urban boundary layer is different from that of urban canopy layer because in urban canopy layer, every building will go on to have its own atmospheric condition, its own canopy. That is, every building will go on to have a canopy associated with itself. Will go on to have a layer of air associated with it. So urban boundary layer is the one that goes on to be very, very high. It can be 6 kilometers, 7 kilometers high. While urban canopy layer goes on to be above almost every building of sorts. This is the basic difference between UBL and UCL. Now this requires to be explained with the help of a diagram. Within the UBL, that is what we have to explain. Within the UBL, the candidates are required to explain the various components of the climate. For example, what is the composition of the atmosphere? What is the temperature of the atmosphere? What is the wind pattern in this case? How is it that the moisture conditions going to be there? And if there are any other atmospheric phenomena associated with it. Now, picking up composition, the composition of atmosphere within the urban boundary layer is going to be very, very different because the urban areas compositionally go on to be very, very distinct from the adjoining places in the sense that they're going to have a very high amount of a particulate material and they are derived from a lot of construction activity taking place in the urban area. They are also going to be derived from a lot of construction activity also taking place by way of roads and other things as well. They're also going to derive from a lot of vehicular motion that takes place on the roads which go on to spill a good amount of dust particles and other things as well. And also that also goes on to comprise some amount of the particulate materials that are derived because of a constant deforestation taking place in the urban regions. Some of these urban regions may go on to have some mining activity as well. Second is the composition is different because there are going to be a lot of pollutants. For example, the fumes that go on to be spewing out of vehicles, vehicular emission goes on to spew a lot of it. So they will going to comprise of CO, SO2, CO2, etc. All of it go on to have a major role to play in altering the composition of the atmosphere. Second is temperature. The temperature within the UBL is going to be very, very different, and it's generally because of its difference, because it is going to be very high, it's going to be called by the name of urban heat island. Urban heat island basically means that is the temperature of the urban area is going to be very, very different from that of the adjoining areas. So one of them is going to be, why is it that the temperatures are very high? The reason is, one is all the urban area is made of asphalt and concrete that have a very, very high absorptive capacity. Second is there are going to be a lot of heat generating structures like cars, vehicles, industries, air conditioners, etc. The third is the greenhouse effect that goes on to take place within the urban area. The fourth is some type of an effect that goes on to take place also because of the loss of the forest cover that goes on to increase the urban area. The fourth is because of what we're going to be calling it a sky view factor. Two buildings very close to each other, and they're so close that one building goes on to radiate its cooling, and when it goes on to radiate its cooling, then this cooling doesn't go on to find its way back to space. It doesn't going to find itself back to space, and then it is going to be trapped by another building as well. So because two buildings are going to be so close, one of these buildings will not be able to radiate its heat back into space, that will be trapped inside. Urban heat island is also because of the fact that the urban areas don't going to be having a good amount of water bodies, and all of these water bodies have been eaten away by the expansion of the urban areas into certain type of ecosystems. So temperature is different. The wind movement within the urban area is very different. There is an urban circulation that goes on to take place, that is in the peripheral urban areas. There is always a wind that keeps on going from the rural areas to the urban areas, and then it rises, then it again goes on to sink and subside, goes on to form a cell. It goes on to form a cell. It's a tertiary circulation. It's a small scale local wind that goes on to be called by the name of forest winds, sometimes urban winds as well, because the air having been heated in the urban area goes on to rise, it goes on to sink in some other place, and then goes on to find itself in the form of a return flow. The second is most of these wind patterns in the urban area go on to be sensing an obstruction. Certain type of an obstructions taking place allows the urban areas to develop certain type of a wind pattern that will go on to be very, very peculiar. For example, between two buildings, the winds that will go on to move, at a faster speed. This is going to be called as a Venturi effect. The speed of the winds in this case will go on to become very, very high. Venturi effect is what we're going to be calling it as. That's another component of it. The third is going to be associated with the moisture and the rain conditions. The moisture rain conditions in urban areas are very different from the adjoining areas, particularly within the UBL. And this is largely because the urban area is going to having a lot of hygroscopic particles. They may going to have a lot of non-hygroscopic particles as well. Both of them can go on to allow a good amount of deposition of moisture on it, and may go to lead to high amount of rainfall, may not be. The relationship between the particulate materials and other things is not going to be very, very clear at all. That was question number 3C. Now that goes on to bring us to question number 4A. We are talking about discuss the origin of any feedback mechanism as part of climatic change. So what have we described here is that the first thing that is described is what is climatic change. And when anyone is describing this topic of climatic change, then they have to separate it from the three terms: climatic variation, climatic cycle, and climatic fluctuation. All three of them: climatic variation, climatic cycle, and climatic fluctuation. Having discussed that, they will go to talk about there are many causes for such type of climatic change. Some of them are going to be catastrophic, some of them are gradual. A catastrophic climatic change will going to take place if the earth collides with a meteor. A catastrophic type of climatic change will going to take place maybe because of volcanic activity. But by and large, most of these climatic changes that are taking place, they take place in a very, very gradual manner. So most of them are going to be gradual. And they're going to spread over something like some hundreds of years or thousands of years as well. That's why it is going to be called as a climatic change. But otherwise, let's say Rajasthan starts having a high amount of rainfall now, more than the amount of rainfall that it was having some 10 years back. It is a climatic trend rather than climatic change. The feedback mechanism is about one of these factors goes on to lead to another one, which leads to another one, which leads to another one, and so on and so forth. For example, one of these feedback mechanism can be, and that has been happening in the Sahel region in Africa as well. People went on to deforest the region. Deforestation caused the surface color to change. Deforestation was associated with then thereafter a lot of absorption of the solar rays. The absorption of the solar radiation caused, in this case, a temperature to increase. An increase in the temperature caused some of the plants to become unadaptive, and then these plants went on to wither away. That has been one. It has been one feedback. Because of the withering away of the plants, the forest area was cleaned once again, the forests went to die, then the temperatures went on to increase once again, and so on and so forth. So, loss of forest cover, a striking of the solar radiation, increase in temperature, change in the climate, loss of forest cover, then again baring of the surface, again increase in temperature, that is feedback. Take another example. That is the feedback. We're going to change the mechanism in this case. That is, the forest cover in the Sahel region has been changed. So what it goes on to do is that it goes on to increase the albedo of the surface. It goes on to increase the reflectivity of the surface. So once the albedo has been increased, once the reflectivity of the surface has been increased, reflectivity allows, or albedo, loss of the radiation goes on to allow the temperature to drop. Once the temperature has been dropped, then the air adjoining the surface goes on to become cooler, heavier. It goes on to sink and goes on to show a tendency for an anticyclonic circulation rather than a cyclonic circulation. An anticyclonic circulation will never ever lead to rainfall. And because it is going to be devoid of rainfall, consequently it will go to increase in aridity even more. So aridity will keep on increasing because of all of these factors. So one factor. See how is the feedback mechanism goes on to work. Deforestation led to the wiping of the forest cover. loss of the forest cover goes on to bare the surface. Baring of the surface goes on to cause the albedo to increase. Increase in the albedo goes on to cause the temperature of the air to drop. A drop in the temperature goes on to lead to high pressure. A high pressure goes on to lead to anticyclone. Anticyclone goes on to lead to loss of rainfall. Loss of rainfall goes on to lead to loss of moisture. A loss of moisture will go on to lead to, again people going for deforestation. Deforestation will again going to lead to baring of the surface. There can be a third factor as well. For example, somehow if the snow cover over the Himalayas goes on to increase, the increase in the snow cover of the Himalayas will go on to cause the albedo to increase. And once the albedo goes on to increase, then the temperature goes on to decrease. A decrease in temperature will go on to lead to expansion of the snow cover even more. The snow cover expands, then the albedo goes on to increase even more, the temperature goes on to drop further, and a drop in the temperature will further go on to lead to expansion of the snow cover. And gradually it will go on to lead to the advent of an ice age. That is how the answer was to be written. That is 4A. Come to 4B. That is, what is thermohaline circulation and what are the implications of its obstruction? The first says what the candidates have to explain it. What is the meaning of thermohaline circulation? So thermohaline circulation is one such type of a circulation that takes place that is driven by temperature and salinity. Thermo, that is temperature, haline, that is salinity. So any current, any circulation that is going to be driven by temperature and salinity conditions is going to be called as thermohaline circulation. Now, we don't go to using the words currents at all. It is going to be all about circulation. The most prominent of this thermohaline circulation in the world goes on to take place in three places. One is towards the southeast of Greenland, that's one. And second is going to be just towards the southeast of Okhotsk Sea. There are two places where a major event of this form takes place, and an upwelling phenomena that is going to be taking place in Indian Ocean as well. So there are three prominent regions. The two most prominent places go on to be towards the southeast of Okhotsk Sea and southeast of Greenland. Towards the southeast of Greenland, what is happening is, that is where there is a convergence of three currents. One of them is going to be called as the Labrador current. Second is East Greenland current. The third is the North Atlantic drift. There are going to be three of them. Three currents that go on to meet. The meeting of the three currents goes on to lead to mixing, densification, and that also goes on to lead to cobbling. Think of it, three currents meeting, and because of the mixing of these three currents, the density and salinity of these currents goes on to increase. That's explained with the help of once this goes on to increase, what it will go on to do is that increase of the temperature conditions in this case will go on to cause is to sink, the currents to sink, the water to sink. The sinking of this water will go on to lead to cobbling. And this sunken water will go on to move on the bottom of the Atlantic Ocean. And then moving on the bottom of the Atlantic Ocean, it will go on to move all the way to Pacific Ocean. It will go on to move all the way to Indian Ocean. Now this is driven by temperature and salinity, consequently called as thermohaline circulation. Now having explained thermohaline circulation, the candidate will go on to explain how is it that this thermohaline circulation is going to be obstructed. The one obstruction that will go on to take place is because of the melting of the icebergs or the glaciers of Greenland. The melting of the Greenland glacier will go on to allow a good amount of fresh water to get spread on the surface. The spreading of the fresh water on the surface will go on to cause all of this movement to get obstructed. And once all of this movement goes on to get itself obstructed, the obstruction of this movement will go on to cause even more spreading of this water, colder water that has been derived out of Greenland. So what will happen is, somehow if Greenland's icebergs go on to melt, then this will going to get itself spread over the whole of the North Atlantic region, and that will going to obstruct the thermohaline circulation. The net impact will be that the warmer currents will not be able to move towards the north, and its impact will be that the entire of North America will go on to freeze. Some of these candidates who may have seen the day after 2012 as well, the day after, this is what was the mechanism that was actually shown. That is, because there was an obstruction of the thermohaline circulation, consequently, and that obstruction ultimately led to the complete blocking of the thermohaline circulation because of the melting of the Greenland icebergs, and then so much amount of a change took place. That is question number 4B. Come to question number 4C. Question number 4C is about discuss the supercontinent cycle, its causes and the future of the world. Question is discuss the supercontinent cycle, its causes and the future of the world. The first thing that the candidate has to explain here is what is a supercontinent cycle, what is plate tectonics, because supercontinent cycle is an extension of the concept of plate tectonics. Plate tectonics concept has been worked upon by one gentleman called F. Tuzo Wilson. He was the one person who went on to work with it. He was the one who went on to evolve this concept of a supercontinent cycle, and what he said was, that is, this supercontinent cycle is about all the continents colliding, recolliding, separating away, recolliding, separating away, recolliding, forming a supercontinent, then a superocean, forming a supercontinent and a superocean. What it actually meant was that they went on to evolve this mechanism and went on to prove it beyond doubt also that in the past on the earth there had been 8 such instances where all the continents collided, leading to formation of one supercontinent like what Wegener talked about some time back, Pangea. And then it went on to get itself fragmented, and then it again went on to collide and so on. It happened 8 times in the past. What is going to happen now is, the mechanism that is taking place is the entire of the Mediterranean Sea will be melted. It will be eaten away. The entire of the Pacific will go to subduct beneath Eurasia. These are the two things that are going to be very, very visible. And along the East African Rift Valley, Africa will also go to break away. Now, the net result will be that the change that will going to take place in Africa will be twofold. Africa will go on to collide with Eurasia, Europe particularly, and in the process of collision it will go on to lead to formation of a very large mountain, very, very tall mountain like that of the Himalayas, extending all the way across from Spain to that of Italy to Moldavia and then to Hindu Kush. That's one change that will going to take place. It will also going to lead to the evolution of a Tibetan plateau-like feature in Europe, and whole of Europe will go to rise as high as that of Tibetan plateau. Second change with Africa will going to be, Africa will going to break itself apart along East African Rift Valley, lead to formation of a different island. That's the second one. With respect to India, the change that will going to take place, that will going to be, Himalayas will keep on moving inside Eurasia, keep on moving inside, and there's a distinct possibility it will going to lead to evolution of a small range where North Bihar plains are right now. So where North Bihar plains are right now, and the plain regions that will go on to have a small folded mountain as well. The third is with respect to Pacific. The whole of Pacific Ocean will be consumed beneath Eurasia, and North America will ultimately go on to get itself colliding with that of Asia. So North America, Eurasia, Africa will go on to form a single supercontinent of sorts. What will happen to Australia is that there is a Cosgrove mountain range that will going to be taking place in Africa, Australia, and there will be the evolution. There will be a evolution of an island arc all along the Bass Strait region. In North America, a small change that may going to take place is that that California may go on to get itself separated away, and that is going to be existing there in the form of a small island of sorts, forming a small lacustrine lake as well. This is what is going to be the future of the world. That's question number 4C. Question number 4D is identify different types of dune, illustrate them and show their formation. Now, any question of this type where illustration is going to be required, that's going to be very mark stretching. So we are talking about identify different types of dune, illustrate them and show their formation. What the candidates have to do is that they have to first going to begin by explaining what is a dune. That's one. So once they've explained what is a dune, then they will going to say that dune is a depositional feature that goes on to take place because of the deposition of sand particles. Now this deposition of sand particles can go to take place in two ways. First is it can go to take place in the form of a free dune, in the sense that is where the motion of air and the air circulation and the wind pattern will be significant in the formation of a dune. For example, a dome dune will go to form when the air goes on to converge from all the sides. A longitudinal dune will go to form when the air goes on to flow in the same direction as that of the dune, and that will go on to lead to formation of a longitudinal dune, a sheaf dune as well, or a whale-back dune as well. A transverse dune is going to be across air motion, and a variant of transverse dune can go on to be acal dune. A Barracan dune is the one that will go on to lead to, it will go on to evolve when there is going to be, the wind speed is going to be very high, and it will go on to lead to formation of certain type of vortices. When the two horns of the Barracans will go to get itself blown away, it will go on to lead to formation of a dome dune. And when the winds will go on to converge from a different direction, it may also go to lead to formation of a star dune. There are two variants of it. That is of longitudinal dune. One of them is going to be called as Dra and the other is called as Rauds. Two of these variants. So Dra is going to be larger than longitudinal dune and Rauds are going to be even larger than longitudinal dune. Second type of dune is going to be called by the name of impeded dune. Impeded dune is a comprising of a parabolic dune. So parabolic dunes go on to evolve wherever there is an obstruction, and this obstruction will go on to lead to formation of a Barracan-like shape, but then the wind speed and wind direction in this case will be completely opposite. And then there are going to be various forms of obstructed dunes like Nebka, Sepka, Lunate, Crescent, a climbing dune or a falling dune. That means a dune will go on to climb along an obstruction, it will go on to fall also along the obstruction. But all in all, in every case, the major significant aspect has been there has been one obstruction around which these dunes are developing. Now, since this topic goes on to include drawing of something like some 14-15 diagrams, the candidates can go on to get almost 10 out of 10 in this type of a question. There is no question of a candidate losing marks in any manner at all. That is question number 4. The fifth question is, there are going to be 5 sub-questions associated with it. One is, 5th A is, discuss the karstic saucer theory of atoll formation. The candidates have to begin by explaining what exactly is an atoll. So an atoll is different from that of fringing reef. It is going to be different from that of a barrier reef as well, or even patch reef or any type of a reef. Once explained that, then they have to explain how many ways is it that an atoll can go on to form. So there have been some theories like subsidence theory, like glacial control theory, which will go on to allow it to form. Glacial control and subsidence theory. So there are so many ways by way of which it can go to form. The third is going to be associated with having explained these theories. The candidates will go on to say that there are some limitations with some limitations with subsidence theory and glacial control theory, and that is why karstic saucer theory went on to evolve. So karstic saucer theory goes on to assume that there is already a limestone surface that goes on to evolve, and as the sea level goes on to rise, it will go on to lead to formation of the corals. The corals will go on to evolve, and the tabular structure that goes on to evolve, that will go on to develop a rim-like a structure. It is around this rim that a fringing reef will take place, that will go on to convert into barrier reef, that will go on to lead to formation of atoll as well. That is one of these theories given by Yabe and Asano. So of course it goes on to assume that there is already an existing structure. So it has certain limitations as well. That is question number 5A. 5B is about explain the law of sea and blue water navy as a policy mechanism. The candidates have to explain what exactly is law of sea. So law of sea is going to be all about a institution and a law and a systematic derivation of a UNCLOS, United Nations Convention of Law. Law of sea went on to define for every country, baseline, internal waters, the territorial sea, contiguous zone, and EEZ and the high sea in that order. That is law of sea. So first beginning with the land, then the baseline, that is two headlands connecting each other that goes to form a baseline. Within the baseline lies the internal waters. Away from towards the ocean, open ocean, lies the territorial sea, up till which the country's sovereignty goes on to lie. And then beyond that, exclusive economic zone, it's a contiguous zone, which is going to be a transitional zone between EEZ and that of territorial water. And then the EEZ, that is 320 nautical miles in this case, and beyond that is high sea. Now, if you're going to take a look at it, the question goes on to say, explain the law of sea and blue water navy as a policy mechanism. So we are talking about a policy. So there can be two types of policies associated with the law of sea. One of them that goes on to take care of your internal waters. That means the waters that goes to be just adjacent to the coastal areas, which is going to be called as a grey water as a policy mechanism. The water is grey, and that is one part that can be manned by even coast guards, even small ships and vessels as well. That is going to be one component of it. The second is going to be that of blue water. The blue water mechanism in this case goes on to mean that the countries concerned will go on to take care of the open ocean, a vast open ocean in this case. Blue water as a mechanism means that the countries will be patrolling the high seas and they will go on to have a territory in the form of a ship as well, in the form of a submarine as well, or in the form of an aircraft carrier as well. So when the countries start manning the entire of the open ocean away from that, so much so that they're able to take care of the traffic that is going to be moving on along the high seas, and also they're going to start taking care of the fact that these are some of these areas where some amount of mechanism of movement will go on to take care of the country's high sea interests and going to expand the suzerainty of the country, the influence of the country. That is the blue ocean mechanism. So from a perspective of defense mechanism, blue ocean water strategy will go to comprise of the use of a aircraft carrier, of course aided by submarines, aided by reconnaissance surveys, aided by a good amount of aircraft that will go on to flow in the form of a formation. The idea in this case is that the country is able to man its waters far and wide as well, and will be able to protect its coastal areas. That is blue ocean strategy, blue water navy. That's question number 5B. Question number 5C is discuss the different types of temperature inversion and its implications. What this question meant was, the candidate had to explain what is inversion, what is temperature inversion. So temperature inversion is effectively that is the temperature, instead of decreasing all along the troposphere, in some places it starts increasing. That means the normal form of temperature in this case is going to be about the decrease of temperature, and in some places the temperature state starts increasing instead of decreasing, and that is the phenomena that is going to be called by the name of inversion and temperature inversion. This temperature inversion that takes place, that can go on to be of two types. One of them is going to be low level inversion, second is high level inversion. A low level inversion will go on to comprise of radiation inversion, advection inversion, Lee inversion, etc. Now radiation inversion will go on to take place if the surface is getting itself cool, cools at the surface, keeps on cooling. The cooling of the surface will go on to allow the air adjacent on the surface also to be cooled. So the surface goes on to get cooled because of radiation. It happens in certain favorable circumstances like that of clear skies, anticyclonic circulation, light breeze, the nights are longer, the surface itself is cooler, it's a winter condition. So the air adjoining the surface also goes on to get itself cooled. Once the air adjoining the surface goes on to get itself cooled, then the cooling of the air adjoining the surface causes the air to become heavy. The heavier air goes on to sink, and once this heavier air goes on to sink, it rests in that place. So you have cooler air at the surface and then warmer air above. That's radiation inversion. Advection inversion generally goes on to take place when two cool currents and warm current go on to meet. So when warm and cool currents go on to meet, then the air associated with the air parcel associated with the cool currents go on to be on the surface, and then the air parcels with warm currents go on to move above the surface. So think of it. Cooler air below, warmer air above in this case. And as it is that the cooler air is below and warmer air is above, that again goes on to lead to inversion. This is called as advection inversion. So in either case, radiation inversion or advection inversion, in either case, the air does not go on to rise. Then there are going to be some high level inversions as well. For example, frontal inversion. Frontal inversion will go on to take place because two air masses will go on to meet. Cold air mass and warm air mass. So a cold air mass and warm air mass, as it goes to meet, the cold air mass will be below and warm air mass will be above the cold air mass. That means above 6 km or 7 km. This type of inversion that will go on to take place, very high up, 6 or 7 km high in the troposphere. There are going to be two more forms of inversions: convective inversion, subsidence inversion, and trade wind inversion as well, right? So all in all, there are going to be some 6-7 types of inversions. The impact of this inversion is, as the topic goes on to ask, and its implications. So one of these implications is that climatological implication that goes on to lead to formation of high pressure. Second climatological implication is that it goes on to lead to anticyclonic formation. The third climatological implication is that it goes on to allow the air to become still. It doesn't go on to allow the air to move also. The non-climatological implication is that if there are going to be some amount of pollutants within this anticyclonic circulation, within the temperature inversion zone, then the pollutants go on to remain there and then there itself. These pollutants don't go on to get themselves dispersed at all. In the absence of the inability of this air to get dispersed, then the pollutants go on to start building up. And once these pollutants are built up in this place, the building of these pollutants will go on to cause the pollution level to become very, very high. Maybe the candidates can go to extend this a bit further, because in the Western European countries where such type of an anticyclonic and high pressure condition going to remain for about months or so, it is like a gloomy condition. It's called as anticyclonic gloom, where fog is there, the movement of the air has gone to become still, the pollution levels going to become very high, and the people going to be having a tendency to become and to feel depressed as well. So such type of a depressive aspect goes on to become very, very troublesome for these type of countries. That is question number 5C. Question number 5D is about describe groundwater in relation to Great Artesian Basin. Essentially, there are two parts of this question. One is about description of groundwater, and second is about what exactly is Great Artesian Basin and how is it that this Great Artesian Basin goes on to exist in this place. So groundwater is that form of water that completely saturates the surface, that completely saturates the pore spaces of the soil. The groundwater goes on to comprise of two zones, aeration zone and saturation zone. The base of the aeration zone goes on to be water table, and the topmost level of the saturation goes on to be also called as water table. And The bottom of the saturation goes on to be called as the capillary zone, where a good amount of water goes on to get itself withdrawn. The water that goes on to remain in the water table is dependent upon the type of a material that goes on to be there. This material can go on to be certain things like clay. Now, clay will go on to have very small pore spaces, will go on to have an enormous reservoir of water. That will go on to show that its porosity is very, very high. Now, this surface can also go on to become such type of surface where the particles are going to be very, very large. Now, when the particles are going to be very large in this case, then it will not going to store that much amount of water as it will go on to transmitting this amount of water. So that will go on to mean that its permeability is very, very high. The porosity is very high. With respect to clay, permeability is very high by way of certain things like boulders, conglomerates, and so on. So wherever the water goes on to get itself accumulated, that is what we go on to be calling it by the name of an aquifer. This is going to be name of an aquifer, and these aquifers can be extensive or they can be not extensive. Artesian Basin is one such type of an aquifer. Now, in Artesian Basin, the water that goes on to remain, that has remained in this place for a good amount of time, and it is under great amount of a confining pressure to such an extent that there is an intake basin from where the great Artesian Basin goes on to be taking its water from, and the water, since it goes on to be under great amount of a confining pressure, I repeat, great amount of a confining pressure, then because it goes on to be under great amount of a confining pressure, any amount of a hole that is inserted in the great Artesian Basin that allows the water to erupt on the surface in the form of a fountain. So Artesian Basin is going to be one of the greatest reservoirs of water that we are going to be having in the whole of the world. So that way it consists that way it goes on to compare itself with the Oblala aquifer, the Hamza aquifer, then the Great Artesian Basin and the Gangetic aquifer. That is the relationship that was to be explored. The next question is about the relative significance of, this is question 5E, that is the relative significance of new methods of exploration of Earth's interior. Now, if the candidate is going to take a look at it, that is relative significance of new methods of exploration of Earth's interior, that means it's a discussion, and that means that they have to talk about the previous significance portion as well. That means they have to talk about the one method of investigation of the Earth that had been by and large existing. And then they have to talk about what have been the new methods that have been in vogue with respect to the exploration of the interior of the Earth. So they have to begin by talking about that the interior of the Earth can be explored with the help of some conventional methods, some non-conventional methods, and seismic methods, and some very modern methods. The conventional methods will go on to be including density. How is it that anyone can go on to know about the density of the Earth? Is by comparing that the density of the crust is going to be 2.6 or 2.5 and the density of the core is going to be 11 or 12. That means intervening density of any of these materials like mantle is always going to be very, very high. That's one way. The density of the whole of the Earth is 5.5 and that of crust is going to be 2.5. That means that the density of the inner materials is going to be very, very high. That's one. The second conventional method is some people have talked about that because volcanic activity takes place and that molten lava comes from the surface, that inside must be having a very, very high temperature. That's also correct as well. So these are conventional methods. The other conventional method in this case has been by seismic investigation. Now, seismic investigation goes on to help getting to know about the interior of the Earth in a somewhat different manner. Now that is seismic waves. What they're going to do is that as they go on to get propagated, they have certain characteristics. Their speed goes on to depend on, there are two types of waves, P waves and S waves. The velocity of the P waves is going to depend on density and a compressibility. while that of the velocity of the S wave is going to depend on density and rigidity. So if the inner surface is going to be very, very rigid, then the speed of these waves will keep on increasing. It will going to increase to a large extent. So higher the speed of the waves, that means higher the speed of the waves, the greater is the amount of density inside the earth. That is one component. Second is S waves, as they go on to get themselves propagated, they don't go on to get propagated where there is a liquid, because their speed or velocity is going to be dependent upon rigidity. So some places which goes on to be having zero rigidity, like that of the low velocity zone, or like that of asthenosphere, in these places they don't going to propagate and they're going to get completely lost. Maybe they're going to get actually completely lost in the outer core, which goes on to show that there is indeed something called as an outer core, because these waves go on to get lost. That is one way. This is a primary investigation that we're going to have with respect to seismic waves. So P waves go on to let us know that as we go on to keep on increasing inside the surface of the earth, then the velocity keeps on increasing with a break in the velocity that goes on to take place in low velocity zone as well as in outer core. And then the S waves keep on increasing its velocity till they're going to get completely lost somewhere near what we're going to be calling it as outer core. So outer core, because the place where they're going to get completely lost is what we're going to be calling it by the, this is the place that we go on to have a liquid. This is the place that goes on to be completely liquid in nature. Other than these two methods, the third method that we have observed is going to be called by the name of free earth oscillations. Now free earth oscillations have two types of motions, spheroidal and torsional, two movements, and they're going to be banking on things like when an earthquake goes on to hit the earth, the whole of the earth starts behaving like that of a bell. That means it looks like that someone has struck the earth, and that starts ringing like that of a bell and keeps on vibrating. It is these vibrations that are going to be tracked, they are going to be processed, they are going to be used for the purpose of getting to know that what exactly is the type of interior that the earth goes on to have. And incidentally, it's a lot of complex technique that is going to be involved in this case, but incidentally they have shown that inside the core is going to, inner core is going to be solid, and that the outer core is going to be liquid in nature. That is question number 5E. Now that goes on to bring us on the last of this question, that is question number 6. 6A is about what are the changes associated with ocean currents as it moves from South Atlantic to Western Europe. That is, we are talking about currents, we are not talking about circulation. We are talking about surface currents. We are not talking about thermohaline circulation in this case. So one is that we have defined ocean currents. So ocean currents actually refer to the actual physical movement of water. So there can be surface currents and there can be subsurface currents. That means on the surface the currents can go to move in this direction, while inside the surface they can go to move in opposite direction. But then there is an entire chunk of water that goes on to keep on moving. As North Atlantic currents go on to move from equator to the poles, there are a lot of changes that go on to take place. First is that all of these currents go on to move in the form of a loop. That means they don't go to move in a straight line. They're going to keep on moving in the form of a loop. That is the way that they keep on moving. That means the movement is not a straight, rather the movement is going to be in the form of a loop. That's one. Second is going to be in the form of a gyre. That means as the currents go on to move, then the North Atlantic current goes on to move, they're going to turn, and then they're going to make a complete gyre. That means North Atlantic current, North Atlantic drift, then in this case goes on to be called by the name of Canary current, and the equatorial current, North equatorial current, and then the Gulf Stream. So comprising it, think of it once again, that is Gulf Stream, North Atlantic drift, then the Canary current, North equatorial current, they all go on to form what we're going to be calling it by the name of a gyre. That's one. That's the second change that goes on to take place. The third change that goes on to take place is that as they go on to move towards North Atlantic, they are responsible for causing the sea level to increase. Maybe by centimeters, but they do go on to cause the sea level to change. The fourth change that goes on to take place is that as these currents go on to move towards Western Europe, they are warmer currents, and it is because of these warmer currents that Western Europe is habitable also. Otherwise, Western Europe goes on to be in the same latitudinal zone as Siberia goes on to be, and Siberia is a physiological desert. It's a cold desert of sorts, while Western Europe is very much habitable. The temperature conditions in Siberia don't match with Western European region at all. Now, this is the type of a change that goes on to take place with the movement of the currents from South Atlantic to Western Europe. 6b is explain the movement of insolation as part of energy transfer between Sun and Earth. Explain the movement of insolation, that is incoming solar radiation is movement as part of energy transfer between Sun and the Earth. That means the journey of this question has to begin all the way from the Sun and it has come to the Earth. So, the first thing that has to be defined by the candidate is what is insolation, incoming solar radiation. The incoming solar radiation goes on to begin its journey somewhere from the Sun. As it goes on to begin its journey from somewhere from the Sun, then Sun has a very high temperature. This high temperature is largely because of the fusion processes that are taking place on that. So because of the carbon cycle on the surface of the Sun is able to convert its hydrogen into helium in a series of 6 consecutive nuclear reactions, which is called as carbon cycle, and ultimately it leads to the formation of it goes into conversion of hydrogen to helium. The temperature that is going to be derived from the surface of the Sun is going to be closer to that of 4000 degrees centigrade, somewhere 6000 degrees centigrade, and solar flares can go on to be associated with and prominences even 1 lakh degrees centigrade as well. So, Sun starts radiating these energies away from the surface, following Stephen Boltzmann law and Wind's displacement law. As the Sun emits this energy, then the energy that is going to be emitted goes on to be of a very short wavelength radiation, as well as other forms of radiation as well. Now the short wavelength radiation goes on to comprise of alpha, beta and gamma rays, X-rays, UV rays as well, and it goes on to also comprise of the visible range as well, and some amount of a very minor amount of infrared radiation, a very minor amount of it. But majority of it is going to be in the form of very short wavelength radiation. That is a lethal form of radiation. Alpha, beta and gamma radiation goes on to get itself taken care of by the magnetosphere. That is, some of them going to get deflected, some of them going to get absorbed on the top of the magnetosphere, and when they going to get themselves absorbed, they transfer this energy on the top of the magnetosphere on the surface of magnetosphere. They allow these atoms, which is going to be in atomic form, to vibrate, and so much amount of energy transfer goes on to take place that they vibrate in such a manner that they start glowing ultimately. It is this glow that ultimately goes on to take place that is largely responsible for auroral display taking place on the surface. It is this auroral display that goes on to take place on the surface. That means the energy goes on to get self converted into aurora. Some of them going to get deflected by those magnetic field. So now the Earth is bare fit of that alpha, beta and gamma radiation. Left is X-ray. X-ray goes on to get self absorbed in the ionosphere. In the ionosphere, the X-rays go on to strike the atoms, and by striking they go on to cause the dislodgement of the electrons from the atom. The dislodgement of the electrons goes on to cause the ionosphere to become positively charged. That's the reason it is called as ionosphere. So X-rays are filtered out. Left is ultraviolet radiation. So ultraviolet rays come onto the surface, And as they're going to be coming onto the surface, then they're going to encounter ozone. Ozone is able to absorb ultraviolet radiation, goes on to increase its temperature, goes on to allow itself to have some collision. So oxygen goes on to colliding there. So O and O goes on to take place, and it goes on to lead to dislodgement as well. So the entire of the ultraviolet radiation goes on to get self-absorbed in ozone. So alpha, beta, gamma gone, X-rays gone, UV rays has gone. Now the rays that going to come onto the surface is going to be in the form of visible range. Now good number of candidates will going to write that short wave radiation goes on to find itself onto the surface of the earth following some NCRT books, but then that is wrong. Had it been short wavelength radiation, then all of us would have been a cancer patient on the earth. It's visible range. It's visible. It's the characteristic of the visible range that goes on to get self divided into 7 colors. That is a vinegar, violet, indigo, blue, green, yellow, orange, and red. It's not the characteristic of the short wavelength radiation. So we don't receive short wavelength radiation on the earth. Mind that part. So visible range is what exactly that we're going to receive on the surface. This is the way that energy is going to be transferred from the sun to the earth. That is question number 6b. Question number 6c is going to be about explain the role of mountains and mountains as an obstruction in generating weather phenomena, particularly in tropical areas. The first thing that we have to explain here is the weather phenomena. What exactly is weather and how is different from climate? So weather is a local phenomena. That means it's a day-to-day phenomena. It's not that we have to talk about climate and climatic aspects. We are going to be talking about day-to-day phenomena here. So there is going to be weather phenomena. Now this weather phenomena that we are going to be experiencing here is going to be in tropical regions. So we are not going to be concerned in Antarctica. We are not going to be concerned with whatever that is happening in the Arctic region or in the northern portion of North America. We are going to be concerned with whatever that can go on to happen in countries like that of India. So it's a maybe India-centric question of sorts. Mountains going to play a variety of roles in weather phenomena. Once you have described weather phenomena, then you're going to say the weather phenomena is going to be determined by temperature, moisture, elevation, altitude, etc., etc. Altitude has a role to play. For example, what is the role that the mountains can go to play? Take an example. You can go to begin from anywhere. One is that it goes on to accentuate rain, and it goes on to lead to formation of orographic rainfall. That's one. This is very much visible in Uttarakhand. Good amount of monsoonal winds that go on to cross the Tarai, they go on to pick up even more moisture, and then they're going to climb up the mountains. And when they're going to climb up the mountains, they're already rain laden, they're heavily sedated with moisture, and as they go to rise, they lead to torrential rainfall. That's one with the phenomena. Second is, Himalayan mountains are responsible for the division of the jet streams into 2 parts. One that is the northern jet streams, another is going to be the southern jet stream. The jet streams themselves go on to cause a lot of weather phenomena like dry conditions, wet conditions, convective conditions, etc., etc. The third is in this case is going to be associated with rotor clouds also. For example, third is going to be associated with the formation of a mountain, and then there is a mountain, and the winds going to move against the mountains. So as they're going to move on the top of the mountain, they will go to lead to banner cloud, and when they're going to descend on the other side, they'll go into formation of a rotor cloud, a cloud that going to keep on moving like that. It's a rotor cloud. These type of rotor clouds are dangerous from the perspective of aviation. Mountains going to lead to formation of another one as well. That is on the least side of the mountain, you're going to find calm conditions. You're going to find clean conditions, clear conditions, not too much amount of cloudy condition. The difference is what you're going to see between that of Mumbai and that of Pune. Pune is more drier, and it receives at least some 4 or 5 times less amount of rainfall than that of Mumbai. That's an example. Then it also mountains also can go to lead to formation of lenticular clouds as well. That is a cloud that can go to be lens shaped. That means as the winds go to descend, they go to move in such a manner, and as they go to move in such a manner, then and on the top of the crest you're going to find one and on the other of the clouds. This is the role of the mountains. Mountains go on to play another role in the sense that is mountains go on to allow on the lee side the winds to descend, and the descending winds are responsible for getting themselves compressed, they're getting themselves warmed, and as they go on to get themselves warmed, the temperature goes on to increase. They are also responsible for the adiabatic heating that goes on to take place. That is question number 6C. 6D is explain why there is so much amount of difference between the rains of the mid-latitude westerly region. Now what the candidate have to do is that they have to explain that what is mid-latitude. That's one. Mid-latitude is anything between about 45 degree plus minus 10 degree or 5 degree, 10 degree north and south. That is mid-latitude. In mid-latitudes, rains going to take place. We are talking about only in the difference in the rains in the mid-latitude westerly regions. So candidate expected that all the places that going to receive rains in the mid-latitude regions, how is it that they are different? There are 4 prominent places where rains going to take place in the mid-latitude region. One is British Columbia, second is Great Britain, the third is Chile, and the fourth is New Zealand. They're all going to lie in the mid-latitude western region. And then there are going to be some deserts that are going to lie in the mid-latitude regions. Like in North America, it goes into Nevada. In Eurasia, it goes on to be Gobi in Siberia, Gobi as well, and Central Asian. In South America, it goes into Patagonia, and so on. Now first, associated with the rains. In British Columbia, the amount of rainfall is very high. That's largely because the Rocky Mountains going to extend themselves and they're going to obstruct the westerlies athwart. That means there is no gap in the mountain. Moreover, there is a complete and a pure obstruction that goes on to be existing in that place. It's a complete obstruction. It's going to be a high range of a mountain, and these high range mountains going to be existing in that place. That's one. So the amount of rainfall is very, very heavy. The same amount of rainfall is not heavy in Europe, largely because the mountains in this case don't go to move in the form of direction of north-south. They're going to move rather east-west. So that the winds keep on moving and they're going to move far deeper. There's only one place where the mountains go on to be by and large in such a manner, that is going to be Norway, the northern portion of Norway, Finland and Sweden. But by and large in Europe, the mountains go on to be not obstructing the entire of the westerlies, rather they go on to be allowing the passageway of the westerlies. That's why the amount of rainfall is low. In Chile, the amount of rainfall is very high, and some of these places like Bahia Felix, for example, goes on to receive 325 days of rains out of 365 days. So the amount of rainfall is very high for the same reason as it is going to be in British Columbia. So there is not too much amount of a difference between the rains taking place between British Columbia and that of Chile. The fourth is New Zealand. In New Zealand, the rains go on to be high, and they also go on to be very, very localized. They go on to present some degree of a localized phenomena. They are almost like that of Britain. That is, New Zealand is an antipodal position of Britain. The basic difference in the amount of rainfall lies in Britain and that of British Columbia. The basic similarity lies in the form of a British Columbia and that of Chile. Now, that is what the students had to explain. That is 6D. The last of this question is 6E. Discuss the changes associated with the movement of polar air mass towards equator. The first thing that the student has to do here is that to explain what is an air mass. So once they have explained what is an air mass, then they have to explain what is a polar air mass. The polar air mass goes on to be having some characteristic. The characteristic that the polar air masses are going to be dry, they go on to be cold and dry. Cold and dry, both of them, they are going to be stable as well. Now, having explained what is a polar air mass, then they can go to pick up different examples. There are going to be 2 prominent examples in this case. 3 prominent examples. One goes on to be North America, North Atlantic, and then going to be Northern Asia. So in North America, the air masses go on to move from north to south. And as they go on to move from north to south, they are facilitated by the movement of the mountain ranges that go on to be from north to south. Had the mountains been east-west, there was no movement of air masses. So in the winter season, when the air masses go on to move from north to south, they go on to bring a real chilly condition towards as far a place even as Texas as well. Some of the students may have known that, that is, New York can go on to have a temperature condition that can be as low as minus 50 degrees centigrade, minus 45 degrees centigrade as well. It can go on to have as low a condition as it can go on to be in Dakota, which has the lowest temperature of recorded at minus 53, 56 degrees centigrade because of the incursion of these cold winds. These cold winds, as they go on to move towards north, they are responsible for changing the complexion of Chicago in one single day. That is, today the temperature conditions may be very cool, comfortable, 24 degrees centigrade, and within 24 hours the temperature conditions going to change to come to minus 25, 26 degrees centigrade. So within one single day there can be a difference in the range of temperature to the tune of 45 degrees centigrade as well. In North Atlantic, the movement that takes place that is going to be of the maritime polar air masses. These maritime polar air masses, as they go on to move towards the northern region, they may go on to come across some type of air masses coming from the south, and they go on to get themselves entangled in the form of a frontal generation. The same type of a frontal generation goes on to take place even in North America as well. So once the fronts have been generated, then thereafter they go on to move from west to east. So in North Atlantic, they are associated with some amount of rainfall, largely because it is going to be moving over a water body. But by and large, maritime polar is also going to be very, very dry. It's not, of course, as dry as continental polar, but it is going to be dry. The most exceptional condition is going to be found to be associated with continental polar air masses that go into North Asia. All of these continental polar air masses that are going to be North Asia, the air will go on to move from north to south, but then they are going to be completely blocked by the Himalayan mountain ranges. And since they are going to be completely blocked by the Himalayan mountain ranges, these winds don't go on to happen to come to India at all. But then they are responsible for making Tibetan region a cold desert as it is. A similarity of this condition, there is some of these incursions that are going to be taking place in China. They are the ones that are responsible for making Manchuria so cold and Shanghai so cold as well, despite the fact that Shanghai and Delhi going to lie almost on the same latitude, and despite the fact that Delhi has a continental location and Shanghai has a maritime location, Shanghai is far more cooler than that of Delhi. That is because of the incursion of these cold polar air masses. This is what the candidates had to write. That is the discussion of this first of this paper.